Hello guys, today we'll be understanding KMP string matching algorithm, which is basically used to match strings in naively, not naively, but linear time solution. So in brute forcing, so naive solution to match a string, let's say onion, to match onion in like per se with another string called, let's call it O N O N O N I O N. Right? This is onion, and this is the other string. So just to match this, we see this is not equal, so we move on and keep resetting, right? And when we reach here, basically we will check this, and this. So this takes n square. Well, it's more, but yeah, n square on average, right? Worst case scenario is also n square, slightly more, but like approximately n square. Okay, just for correctness. Now let's go over the other possible method to do it. Now the other way is to basically have a string hashing solution where we basically hash this, and then we start a window of this size, and then we have another prime number basically to keep rolling, and then we inversely remove its powers by -1. So not -1 but divide by 1, exponentiation method. So this is slightly more complex and requires some understanding of how prime numbers can be used. Uh, I think I'll leave a link below to understand this method. For today, we'll be doing KMP method. So the KMP is basically, it relies on a specific idea called as longest proper prefix, which is also a suffix, right? So longest prefix, okay, longest proper prefix, which is also a suffix, okay? So for this, we basically build an array, and the answer that it gives us is basically that, okay, let's see if we want to if we want to match onions, right? Onions with ONS, let's say ONS, right? Now we want to find this in this, right? For example, just for an example, right? So we know these two are same. We know these two are same. We know these two are not same. So what we usually do is we basically reset and we keep on increasing these pointers to eventually realize that, okay, the string exists here, right? So what KMP allows us is basically lets us find pre-existing prefixes, which are also suffixes, which can be used to move the pointers. What I mean by that is, let's say this is ON onions, okay? Okay, ONIONIS, okay? Let's call it onionies, for example, for now. So we know this is a repeating pattern, right? So we know if there's a mismatch here, we can always say that, okay, if this is not matching and there is an issue, so we can also say that, okay, it can start here or it can start here, right? Now, obviously, because this is not matching, then we cannot reuse this, right? We can just instead try with, oh, if it's not matching, then we have to reset back, right? For any other string to match with this. So let's understand what the idea is. I think after an explanation, it will make more sense. So we always make an array, basically initialize it all with 0. Okay, so 0, 0. This is for each index, 0, 0, 0, 0, and 0. Okay, so this is index 0, 0, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Okay, now we start with two pointers. So I'll just write this again. O N I O N I S. Okay. So what we do is basically now we have two pointers I and let's say J. Okay. I will start at 0. J will start at 1. Now what we want to do is basically find a substring which is not a complete string, not a complete string from I to J. So from 0th index to let's say J, non-inclusive J. We want to find some string which exists from 0 between 0 to J of length, let's say K length, which is equal to basically ending at J, and starting at position, well, K minus J or whatever we want to call it. Okay, so basically this should be also K. Now this is what KMP helps us find. So we can basically recompute the values and use it again and again for string matching purposes, right? So from, let's say, right? So this is non-inclusive, by the way. So because we want proper, so not the complete string. So this is non-inclusive, 0 to j of k length, and this is j minus k to j. Okay. So here we see O is not equal to n, and since this cannot be a complete string which can be equal to itself, but we want proper, so we place this as 0 and we keep on moving. So now the j pointer will move. Okay, j comes to I. Okay, I should have named it actually something else, but let's not confuse between these pointers and this specific character, right? Okay, so now we see O is not equal to I, so we also keep on moving because I is at 0 because there's nothing before this, so we know we cannot make it match with another pattern, right? So we keep on moving. So this goes here, this goes here. O and O are the same. So we say, okay, I and J are the same. So for now, our current I value is at 0, right? So we have exactly 0 length of substring which matches. So if we start matching once, we just add 1 to it. Okay. So this is 0. So this becomes 1. This is index 3. This becomes 1. Okay. And well, the substring that is actually that is basically a prefix, and a suffix is basically these, right? O is equal to O. This is what it answers. O from, let's say, O to J. So length 1, and this starts from J minus K. Okay, and to till J. This is also non-inclusive, by the way. I should have made this like this instead. Okay, now let's keep on moving. Okay, so now J comes here, and I also moves here because they matched. Okay, now when these match again, we can say that this substring is basically equal to this, right? Which is not the complete substring from start to J and is also equivalent. So ON is equal to ON, right? So we can just make it I plus 1. I plus 1 is basically 2. We have a 2 length of substring from the start, which is equal to the current position. So from here, basically from 2 position from here, we can find a substring which starts from 0 to 1. Okay, length this much. So this becomes 2. I should actually use proper colors. Also, I can remove this. Just have clarity. So this becomes 1, this becomes 2. Okay. Now when we come here, we can basically say that okay, these two are the same. Let's keep on moving. Let's move both of them. So I comes on I and J comes on I. Okay. Now we see that okay, hey, uh, are we able to say these both are equal? Yes, they are equal, right? So we know this substring ONI is equal to ONI, which is also not the complete substring from 0 to J, but also equivalent, right? So we can say that this is 3. So we can just remove this one and this becomes 3, right? Okay, wrong color, sorry. 3. Now we come to this point. So we'll move both of these again. Okay, let's move these. This comes here because they matched, and this comes here, right? Okay, so now we know we are at S, right? So we know O is not equal to S. So what we want to do is, okay, let's see, okay, O is not equal to S. So we're just saying, okay, where can we go back? Where can we go back so that we can start matching with S, the current position? So obviously the answer is always going to be for I to reset back. So we are not going to move J pointer ever, right? You're always going to try matching just with I pointer. So I will ask its previous I, not me, I will ask its previous value. Okay, where can I go back? Where should I go back to possibly find something matching with this? And this is 0, right? This stores 0, right? This is 0. This is 0, right? So this basically becomes LPS of LPS array of I minus 1. This will answer, okay, there is nothing we can do to find this. So basically this comes back and this says, okay, O is not equal to S. So we can say that I is equal to 0 and O is not equal to S. O is not equal to S as in I moves back here, right? I moves back here. Okay. I moves back here. But yeah, that's about it. So we're done. We can say this is at 0. There's no possible processing we can do before this. So this stays at 0. And this is the LPS array. We can say at this position, there's a length, there's a length of this much from here to here, which is equal to this. So let's say we have another string. For how does it help us, by the way? Okay, let's answer that first. Okay, let's say we have this. Okay, onis, and we want to match with onis, right? Now we know these both are equal. We know these both are equal. We know these both are equal. Now this mismatches. So let's build an entire LPS array for this. This is 0. This is going to be 0. This is going to be 0. This is going to be 0. So what it says is basically, okay, can these both match? No, these cannot match. So we basically keep on moving. Okay. So these cannot match. So obviously we just try to go from this point. Okay. Oh, we ask previous value. Is there anything we can do? And obviously it will reply, we cannot find anything. There's nothing that exists. This will say this. This will say this. And eventually we reach here. And then we say these match. Then we say these match because we'll increase the pointer for this as well once it starts matching. So this matches as well. And this matches as well. And as soon as we can say that we've basically completed the entire iteration for the smaller string that we needed to find in the bigger string, we can say that we found the string. That is the basic idea, right? Naively, we would be basically processing and comparing each of the character values in the string, which would take n square once again, n square because we would have to match n character, n approximately n char each time to find string in another string, right? So just to understand the code, I think once again we need to basically ask I because J will never move, right? So we need to ask I, hey I, where can I find something that will help me building not entirely pre-processing, but hey, where can I find S again? So we can keep on building up the array so that whenever there's a mismatch with another string, I can start computing from there. Basically, that's it. So when we start here, we can say, okay, there is nothing that is going to help us before this. If there was no S, let's say this was N. Okay. So once we are here, we can basically ask us, hey, where can we restart? And it's obviously going to say we cannot start anywhere because obviously there's nothing that helps us. And we can say that once J exits, once the pointer for this exits, we can say we did not find anything. And if this exits, we can say we found it, right? So let's do another substring actually, just to understand how this works. Now let's say there's a string A, B, C, A, A, B, C. Okay. And let's just put in A again, once again. Okay. Now, okay, we can start building the LPS array. So initially it's going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros. 8 zeros. 1, 2, 3, 4, 5, 6. Yeah. Okay. So these 8 values. I'll just actually move them so things become more clear. Okay. A is here, B is here, C is here, A is here, is here, and hey. Okay. I think we're done, right? Now this will always be 0 because obviously we cannot find a proper prefix from here, which is also suffix and does not include the start value till the end value. So this is always going to be 0. Now we basically have two pointers, which will be j, and well, one of the other one will be I, right? I. Now is I equal to j? No. And is I equal to 0? Yes. So we cannot find anything here. So now this will go. I'll just use this actually and just move it. Okay. Now we ask C, hey, I equal to 0, A? No. So this is also 0 because I is at 0. There's nothing we can do, right? Now let's move this again. Now J comes here. We ask, hey J, I equal to I. Well, obviously it's equal to I. So we can say there is one length. One length basically because I is at 0. I is equal to 0. So I is also giving us the length that we have from the start, right? So hey, I says it's also equal to 0. So J says, okay, for my value at on the LPS array, this is the LPS array. Basically, it says that, hey, I can have basically one substring, one length of substring. So this is the substring that is going to be equal, right? So this becomes 1. Now I will move. Okay, wait, okay, what? Okay, I have to move it manually. Okay, now J comes here, I comes here, and yeah, is I equal to J? No. So basically what we can say is, hey I, can you ask your previous version, can you ask your previous value to move back? So it does move back. It should move back actually. So I goes back to, I will always go back to LPS of I minus 1. So I is currently 1 and LPS of I minus 1 will be LPS of 0. So basically it comes back to 0, right? This comes back to 0. And hey, now we can say A and A are equal. So hey, we know we have another substring which is basically equal to I plus 1. I plus 1 is always going to be the J value if they match, right? So this becomes 1 because this is 0. Oh, this is 0, not this, sorry. This is 0, right? Now we basically move both of these once again. So let's just move these again. B comes, I comes to B, J comes to B. Are these both equal? The answer is yes. So I is at 1. So we can say the current value should become 2 because I plus 1 J, LPS of J, I should write this actually. LPS of J, J equal to I plus 1. When they match, when equal to, when equal to, okay? So this is equal to condition, right? So this will say basically 2. And the string also, we can also see this, right? This is len2 and this is also len2 and these both are equal. This starts from 0, ends at before j. This starts at some point and ends at j, right? So now we will move the pointer once again, right? Let's move the pointers. Uh, I comes to C, J comes to C, okay? J comes to C. So basically what we can say is, hey, what we will be asking, sorry, is, hey, are you both equal? Obviously these both are equal, right? So I is at basically 2, I is 2 currently. So LPS of this will be I plus 1, which is 3. And then we come here at this, oh no, not that, sorry. We come to this point and this point, right? J comes here, I comes here. And well, we can just say this has to go, this has to go, this has to go, this has to go, right? Now what we can say is, are these both equal? Yes, these are. I is equal to 3, so we will put I plus 1 here, 4. So obviously you can see this is the string. This is the string that we're talking about. This and well this is length 4, this is length 4. These are equal strings and also these are basically just, this is basically just saying, hey, at this point we have a length of this much which starts from this and also the condition that we wrote, right? So before j at some point of length k, so from 0 to I, let's say, not I, j, and this is some point of length k, right? So till j. somewhere from, let's say, J. Okay. Okay. Now let's say we want to find this entire string in another string, right? Now we'll actually just give me a minute. Yeah. So let's remake this string. A, B, C, A, A, B, C, A. Okay. Now we want to find, let's say, okay, let's make another string which is basically a copy of this with one change. Control C and I'll control V and okay and control V, right? Now let's just change this one, this portion specifically, and write an S here, like just to have a mismatch here, right? Now we'll have two pointers. Now we'll have this LPS array with us. I'll just rewrite the LPS array actually. Okay. Uh, Wait a minute. I actually have this. Just arrange this into a vector, just to be clear, right? A, not a vector, but let's have this properly positioned. A, B, C, A, A, yeah, A, B, uh, B, C, S, A, B, C, A, A, B, C, A. Okay, and let's have this properly aligned as well. Okay, forgot to close that. Let's close that, and this will be LPS array 0, 0, 0, 1, 1. B is 2, 3, and well 4. Right? This is the LPS array. I'll actually clear this so things make sense. B, C, A, and B. Okay. Now let's start with matching, string matching, right? Now we'll have two pointers. Let's call them, this is R and well this is L, right? Now is L equal to R? Yes, these are equal to R. So we keep on moving forward, right? Yeah. Let's move this L to here, R here. Is this same? Yes. Let's keep on moving. Is this same? Yes. So let's keep on moving. Are these both same? Yeah. Let's keep on moving. Are these both same? Yes. Let's keep on moving. Are these both same? Yes. Let's keep on moving. Are these both same? Yes. Are these both same? No. So what we ask here is, okay. So what we ask here is, this is not equivalent to this. So if this is not equivalent to this, so we ask L, hey L, ask your previous value where we can possibly start matching. So this is not matching, right? This portion is not matching, right? So we'll ask this portion that this portion's ending, this portion's ending. So this C, we'll ask this C, hey, where can we match again, right? Now obviously it will give us the value. So L is equal to L is going to jump to LPS of L minus 1. So L will go back to 3. This is the third value, right? So this is also not going to match again, and this will fall back to 1. So basically what we're going to say is, hey, we cannot ever match it. So if this is not ever going to match, so we're just going to have to process this later on. So R comes here, we're not going to find a match here because obviously it doesn't exist, right? Now L is going to be back at this position, and this should be gone by now. I think this will be also gone, right? Okay. Now we match here. This is the same. Okay, this is the same. 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 So obviously now we've come to the last index and we found a match. So on the next iteration, we can see that L will exceed the length of this, and we can basically just say that we found it because L has found every matching character. And that will be the solution. We can say that this string exists here, right? So this is the only thing that you need to remember, by the way. So you can basically just start solving problems. There's one of these problems, which is basically you don't even need to match a string. It just asks if there's any string that exists, right? So let's solve this, okay? Let's build a vector in, let's call LPS and have it at s.length. Sorry, all of them will be 0 initially. And well, let's just build LPS. Yes. Okay. I'm actually sorry because I'm using a stiff keyboard from Rain and everything. Okay. I'll just actually. Okay. Now we have basically all the values are 0 currently. So we'll start with L is equal to 0 and int R is equal to 1. Why 1? Because we already said that if we find something from here, it's not going to be a proper prefix. And for KMP to work, we need a proper prefix, which is not the complete string till R, right? Or J, okay. We did IJ, right? So I'll just do IJ so we are not confused. Okay. Now, while R is less than S dot length, if both of these are same, so if S of L equal to S of R, we can say there's something that exists at this point. LPSR is equal to of length wherever the L is. Okay, we did. Okay. I'm actually very sorry. J, I, J, and well, this is going to be J. Yeah. So if these are equal, then this is basically going to be I plus 1, right? Now we can also say that, hey, okay, yeah. So we can also say, hey, if these are not matching, if I is already at 0, if I equal to 0, basically if we are already here, so we know there's nothing we can find before this to match. So we can say, hey, there's sadly nothing you can store here. So LPSOJ also becomes, by the way, I forgot to do this, but let's just do this is equal to 0. J plus plus, we need to keep on moving. For this, we also need to do this, right? And okay, and if these don't match, then we can say, hey, okay, if these are not matching, we can ask the previous value to where we can jump. So L is equal to LPS of L minus 1, right? And this is going to basically build a LPS array. And now we're going to build LPS. We've built the LPS, right? We are passing by reference to just have lower value for memory. Now what we want to do is, now once we build this, for this problem specifically, we just need to find an LPS that exists from start till end, right? So we can say if LPS of S dot length minus 1 equal to 0. If the last value is 0, basically if this is 0, then we can say there's nothing that exists, right? There's no proper prefix which is also a suffix. So we can just return empty string. Otherwise, else int length, the length of the substring is going to be this. Okay, and we can just return subst 0 to 0 till length. I think this is the, I'm actually very bad with this, but I think this should work. Oh, okay, I'm actually really sorry. This as well, right? This should work. Hmm. Substr, not doing substr. Basically, this is the basic idea, right? I'll just call it len, just in case if that's the issue. I don't think that is the main issue here. str, wait, how do we write this? String, string, main string dot str. Okay. Right. Yeah, so this should work. Right, this works. So that is the entire code. I hope this makes sense. It's actually very hard to come with, uh, come with, come up with this solution ourselves. So I think you should try this out yourself. Write a few strings. Try to build the LPS array yourself. It's going to be a bit complicated at first, but when you start asking the right questions, I think it starts making sense. Obviously, it's a very hard theorem in my opinion. It's a very bad algorithm. I don't know how they came up with this. It actually required three people to come with this. So obviously give it a try. And yeah, that's it. Thank you.